Hello, so this is Damien and I's project, midterm project. We will be creating an elevator using a linear motion guide rail. As you can see, this is our setup, which I will show more clearly later on after I show you the code. So here's our code. First of all, in the first network, we have the axis configuration block, which sets the initial position, sets whether it's linear or rotary, and also sets the maximum and minimum velocities. And to actually move the elevator, we have these three blocks, which are called axis move to position using S-curve. An S-curve is basically a velocity over time graph. Hence, that comes from the S-curve name, because the velocity over time graph looks like an S essentially. And right here, we set the position value. This is for the first floor, C10. So when you hit this when you're at the first floor, obviously nothing happens because the position value is set to 0, which is the initial value. And it's an absolute position value. And we can also set the velocity here, which is 2,000 pulses per second. And in parallel with this is another memory bit, C13, which will be used to set the floor text on the HMI. As you can see, we have two other memory bits normally closed attached to it to ensure that only one floor is showing on the HMI. And these other two networks are the same function blocks, but now we have the actual floor values. The second floor being negative 40,000, the third floor being negative 75,000, and the velocities are the same across all three function blocks. And in parallel, we have the same things, the two other memory bits for the floor text from the HMI, and obviously the other two memory bits which will allow that are normally closed, which will allow for only one floor to show. And over here we have the HMI setup. Right here we have the three buttons, floor 1, floor 2, floor 3. These correspond to C10, C11, and C12, which when hit it will go to that specific floor. And over here on the right we have the recipe push button, which whenever you hit these, it'll keep that floor displayed on there, as we have right here for the C13, C14, C15. Those three on the right correspond to those three different memory bits, allowing for only one to show at a time. So let's simulate. This is our setup right here. Alright. This is our setup right here. We have the parking garage on the bottom, and then we have first floor right here, and then second floor right here. And this is our elevator carriage. We have Cinderella in there. We line this up. And here we have our HMI. So right now we're at the first floor. We hit floor 2. As you can see, floor 2 is on there, and our elevator is moving right now. So it'll hit the top of the wooden box, which is the parking garage. This will simulate the first floor of a building, first actual floor. And it will stop right at the beginning, right there. Still on floor 2, so now we hit floor 3. And now it moves up to the third setting, which is the second floor in the building, but the third floor overall. You can see it's moving. 2,000 pulses per second. It'll stop right there. And now if you want to go back to the second floor, or floor 1 of the actual building, we go down, and it will stop where it should, right there. And we want to go back down to our car, to the parking garage. I'm going to drive away. We head down. And it will stop right there at the bottom. Now we go over here, our PLC setup. Here's our bus. PLC, we only have two inputs, two outputs to the actual stepper drive, Y0 and Y1. which are step minus and direction minus. These control the direction and the number of pulses that are sent to the step motor. Here's our stepper drive wired in the back here. At the top are the 4 phases of the step motor. At the bottom we have the positive and negative supply to it. We have the step and direction inputs and outputs, and the step plus and direction plus are wired straight to the bus to plus 24 volts right here. And our common, of course, for the outputs on the PLC are wired to negative because they are syncing outputs on the PLC. And yeah, this is our midterm project, and we will clean up the building to make it look nicer than this in the future. Thank you.